talking about circles today. Before we get too into solving stuff about circles, we need to get some vocab. Okay, so circles, let's get some vocab. That was a really funny sound. So vocab, a couple things that we need to know. 4 specific vocab words that we're going to look at. Radius, diameter, circumference, and pi. All right, so radius. Everybody know what a radius is in a circle? Everybody think you got an idea? Desi?
Is it like the halfway point of the circle?
Yeah, it's a good way to think about it. It's a good way to think about it. It's like the halfway. So in our definition, does anybody think they can apply kind of Desi's idea to what our definition actually is?
The middle of the circle.
Well, we got to fill in the blanks, right? A segment that has endpoint at the and the other endpoint on the circle. What do we think, Anna?
I think the first is 2.
2 endpoint.
1.
1. Why does context clues tell us that it should be 1?
Oh, because one endpoint at that
One
end, and then
endpoint. Why wouldn't it be 2?
because it's not plural.
Because it's not plural. That's good. I was just. Yeah, hey, sometimes we can use English to help us out in math. So yeah, 1 is the correct. 1 endpoint at the. What do you think? At the. Not middle. I love this idea. Center. Center is the correct word for this. Middle is a great way to think about it, but center is important. So I want on that circle at the bottom, I want you to find the center. Put a little dot.
Wood. It's hard to find the center.
That's true. It is hard to find the center. So estimate the center. Put a little dot. So then the diameter is the distance across the what of the circle. I love that idea, the whole circle. Unfortunately, it's not as close, not as specific to circles as we want. That's a great way to think about it. The entire and whole, these are great words, but it doesn't apply to circles. I love these ideas. They're great. They're good ways to think about it.
Across the half.
Ooh, getting closer. What did we just say?
Wasn't it radius?
Across the
Center.
center of the circle. Across the center of the circle. So let's go ahead and draw a radius, and then we'll draw a diameter. So I'm going to make the radius green, because that was the words that I had. And so the radius has to go from the center, one endpoint at the center and one endpoint on the circle. So just pick another point on the circle, doesn't matter where you make it. And this is our radius. And I'm going to make my diameter orange, because that's the color I had. And so we can draw this. Both endpoints are going to be on the circle, but what has to be true about it? It has to be what?
Across the center.
It has to go across the center. Okay. Boom. And this is the diameter. Okay? That's the diameter. Keep in mind, it's got to go through that center. All right. And now we need circumference. Anybody know this one?
Oh, yeah, it's like the whole.
The distance.
Around.
I love it. Distance around the circle. In other words, it's the what? What did we learn about last class?
Perimeter.
It's the perimeter, right? It's the perimeter. Now, unlike perimeter, we can't just add up all the sides, right? Because how many sides are there in a circle?
0.
There are none. There are no sides in the circle. So we have to find another way to get a perimeter, and we're going to get an equation for it. Don't worry, we'll discover an equation for it. And then pi. That's going to be an important word for us. Pi is actually not a number. Sometimes it acts like a number. Sometimes pi acts like a variable. And sometimes it acts like a ratio. Because it is a ratio. What pi is the ratio of the circumference. Sorry, I switched up the, when I was making my answer blanks, I switched up the answer blanks. Sorry, so the first one's skinny and the second one's big. I meant to have the first one be big and the second one be skinny. It's a ratio of the circumference to the diameter of the circle. So it's a ratio of circumference to diameter. So pi is equal to C over D. Pi is equal to C over D, where C is the circumference and D is the diameter. This is going to help us figure out the circumference. Because what would I do if I wanted to get C by itself? Think about it, Elsa. What would I do to get C by itself? Good, I said that variable using inverse operation. So what would I do to both sides?
Multiply by
I would multiply by
the diameter.
the diameter. So C would then equal pi times D. That will give us our circumference equation. We estimate pi with these two values. Pi is approximately 3.14 for us, or 22/7. It would be helpful to use 22/7 when you have a number that's a multiple of 7, right? What if we had a diameter that was 28? Well, the circumference would be 22/7 times 28. So it would be 88. The idea being that this one is useful when you're dealing with multiples of 7. This is the one we'll probably use more often. Okay? Bless you. Good. Questions? This is our vocab. So since pi is a ratio of circumference to diameter, if we want to find the circumference, all we have to do is use that ratio and solve for c, right? So here, you guys said, how can I get c by itself? We use inverse operations, right? So what do I need to do to figure out what c is? I need to do what to both sides?
Divide by.
What's currently happening to c? What's currently happening to c?
Being divided by.
It's being divided by d. So the inverse of that would be multiply both sides by d. So what does c then equal? C equals d pi or pi d. That's typically how we write it. So c equals pi times d, where d is diameter. So circumference is actually really easy to find if you have the diameter. You just multiply it times pi. Now, how was the radius and the diameter related? How are they related to each other?
They're at the cross the center of the
That's true. That's how they're related to the circle, though. I want to know how is the radius and the diameter related to each other. The radius is half the diameter, or in other words, the diameter is twice the radius. So either of those works, right? The diameter is twice the radius, or the radius is half the diameter. So if our equation is pi times d, couldn't we split that up and say, all right, diameter is made up of how many radiuses? 2. We call that radii, by the way. Everybody say radii. Radii. It's made up of 2 radii. So we could say pi 2r, but that doesn't look very nice. That doesn't look very nice, okay? We want to reorganize that so that way it goes numbers, then letters. So we're actually going to write it as 2 pi r. So c equals 2 pi r. Notice these are equations, right, with multiple variables. We always need to label our units. Circumference is a distance around the circle, which means that your units are one-dimensional. They're not squared. So the steps. We want to write the formula used. So we just pick which formula we use. When would we use the first formula? If you know the diameter. When would you use the second formula? If you know the radius, right? Just pick which one is easier. Okay? So here we go. Let us proceed. In letter A, which formula should we use? Careful. Formulas have equal signs and a left and a right side. So formulas have a left, a right, and an equals. Do not just pick one side. So, which formula should we use for letter A?
C equals pi d.
Great. C equals pi d. Why would we use that formula? You're given the whole diameter. Why not use the easy one? Now there's 2 formats to your answer. Don't go right to your calculator because you're going to miss a key step. Okay? C equals pi times 10. That's plugging it in. Which means our exact answer is 10 pi. We call this the exact answer. This is our exact answer. Because there's no rounding. So I know that this is kind of weird. This is new. We're going to write our answer as 10 pi meters. 10 pi meters. It's the exact answer. This will be very helpful for us when we get to volume. We need to get in the habit of writing an exact answer. Why is this exact? Because we didn't round. And then we'll also get what's called an approximate answer, which is one where you would plug it into your calculator. C is approximately equal to, and now you would do 10 times pi in your calculator. We're going to use 3.14 for pi. Even if you have a pi button on your calculator, we're going to use 3.14. Okay? So, do that in your calculator. If you see 10 times pi, you know that's 10 times 3.14, right? And what do we get? 31.4. Now, is that an exact answer? No, it's approximate because is 3.14 pi? No, it's approximately pi. This is an exact answer because we didn't round. This is an approximate answer because we did. So we want to be able to do both. All right, now let's take a look at letter B. What's different about letter B? There's a couple things.
It's half a circle.
It's only half a circle. So what am I going to need to do to the circumference equation?
C2 pi r. Multiply by 2.
Just multiply by 2. We're cutting it in half. Shouldn't we multiply by half or divide by 2? Doesn't matter which one you do. I recommend multiplying by a half. So if I see it's a half a circle, a semicircle, we call that a semicircle. Everybody say semicircle. Good. So if we see it's a semicircle, we'd be like C equals 2 pi r, right? Why 2 pi r?
Because you're finding the right half.
But I need to fix this equation. What should I do to it? Put a 1/2 in front of it, right? Or put it over 2. Why?
Because you only have half.
I only have half of it. Now, here's why I recommend doing 1/2. What do you see right away? What's going to cancel? Boop. And I'm left with C equals pi times 7. So my exact answer is 7 pi centimeters. My approximate answer would be plug 3.14 in for pi. What do we get?
Uh,
21.98
What?
centimeters, right? Is that right? 21.98?
No.
7 times pi? 7 times 3.14? 7 times 3.14?
Yeah.
So, the new part, I don't think that going from here to here is too tough. I think that you get that. You're like, oh, I just need to plug it into the calculator. This is the part students are always like, oh, that's hard. It's actually not. It's actually really easy. With the exact answer, you don't plug into your calculator. You just leave it as pi. It's actually kind of nice. You get the door. Thanks. It's just a little loud up there. So that is the new thing. You guys have seen this before. You have. But this is the new thing of having an exact answer. The exact answer is really helpful when we have to work backwards. All right, it's really helpful. Because what if we were told that the circumference of a circle is 70 pi? 70 pi. What's the diameter? How about this? Here's a better question. The circumference of a circle is 20 pi. What's the diameter? 20. The circumference of a circle is 50 pi. What's the diameter? 50. See how if it's in terms of pi, it's a little bit easier to work backwards. If it's like this, it's less easy. Okay? So, big new thing, exact answer, you leave it alone. You just don't plug it in your calculator. Approximate answer, you plug it into the calculator. Make sense? Are we with me? I do just remember that I made a mistake on my notes earlier, and I apologize. Go back to the circumference portion. I apologize for this. I realized that I made a mistake here. I didn't finish the problem. And I apologize for this. Can you go back to letter B on the circumference portion? We only found half the circumference, which means that we found this. Which part did I forget to include?
The other half.
No, there's no other half. The bottom. I forgot to include the bottom. I apologize for that. So that's a tough question because you have to not only think about I have to cut the circumference in half, but I also need to include the bottom. I also need that part. What's that length? This length is 14 centimeters. So I need to add 14 centimeters to my total to get the full perimeter. I apologize that I missed this earlier. Please make sure you make this correction. So if I want to find the total distance around that semicircle, I need to find half the circumference plus the, what's this called? Nope, it has a real circle name, plus the diameter. So we need to take that 21.98 plus 14, and we would get 35.98 centimeters. I apologize for that mistake that I made earlier. Please make sure that you do make that adjustment. One thing you might want to make a note to yourself is, this is half of circumference plus diameter. That's what that is. Half the circumference plus the diameter. That's what that is. All right, now we need area. So that's circumference. Circumference is a distance. Notice the units, right? Notice the units. Meters, centimeters, or I think it's centimeters. Area is an area. So the units are going to be what? Units are going to be squared. Now here's the deal. I'm going to show you where the formula comes from. Pay attention, you're going to watch, and you're going to learn. Okay, so here we go. So stop doing your homework. I'm going to take this, I'm going to split this thing up into 8 chunks. Okay? Now what I'm going to do is I'm going to take those, now this is like a pizza, right? I'm going to take those pieces of pizza and I'm going to lay them out like this in alternating fashion. Here's what I mean. Here's 1 piece of pizza, 2 pieces of pizza, 3 pieces of pizza, 4 pieces of pizza. You with me so far? I just took those pieces and laid them out like that. And now I'm going to lay them out like this. I took those 8 chunks and I laid them out like that, alternating. Some of them are facing up and some of them are facing down. You see it? I took those chunks and I laid them out. What shape does that kind of sort of look like? It kind of sort of looks like a curvy parallelogram, right? And what happens is, if I cut those in half again, and then I cut them in half again, and then I cut them in half again, and then I cut them in half again, and I keep laying them out like teeth, eventually those curves, they'll get less curvy. They'll get so less curvy that it kind of looks like this. It sort of looks, well, that's a terrible version. Let's try that again. Let's try that again. Now I'm just going to keep cutting them in half and keep cutting them in half. And eventually it'll start to look like that. Yeah, perfect. This is a parallelogram. How do we find the area of a parallelogram? A equals B times H. So what's the base and what's the height of this shape? Well, I've got 4 curves here. Here's 1, 2, 3, 4. How much of the circumference is that? So the base is actually half circumference. So instead of B, and you're just going to watch, I have half of C. What's the height from this corner piece to the outside edge? From this corner piece to the outside edge. What's that called? What's that called? That's called our radius. So instead of the height, we actually have the radius. So this parallelogram, which is actually just our circle, area equals base times height, is actually area equals half the circumference times the radius. Well, that's not nice. I don't want to have to know the circumference to find the area. Well, the circumference, we just saw, is 2 pi r. So C equals 2 pi r. Don't forget, we still have this extra r here. Half of 2, what's going to happen there? And we're left with pi times r times r. There's a pi, there's an r, there's an r. How do we rewrite this so it's kind of nice? A equals pi r squared. Not r2, but r squared. Because r times r is not 2r, but r squared. This equation may be familiar to you. How many of you guys, now that you see this, remember that this is an equation that you've learned before? It is. So area equals pi r squared. Now I know that that was an in-depth look at this equation. I'm not going to expect you to go through this all the time. But I wanted you to see where the equation came from. It came from the idea that if you split this circle up into a bunch of chunks, eventually it becomes a parallelogram. That parallelogram's base is half the circumference, and the height was the radius. And therefore you can work your way down. Area equals pi r squared. Okay? So now, we need to have one big difference between the circumference. With the circumference, you're finding length, and you can use diameter or radius. With the area, you can't. You have to use the radius, not the diameter. It's important. Is that equation pi d? No, because that would be circumference. Is it pi d squared? Nope, it's pi r squared. It cannot change. Okay? So, what am I going to do here? Area equals pi r squared. So when I plug in, I have this. Please do this. I know it sounds silly. Set yourself up for success by creating this plug-in. You're creating a space to plug in a number. What number will go in there? The radius. So I plug in 10, right? Wrong. What number do I plug in? Why do I plug in 5? Exactly. This is half of 10. Now let's work our way through. The exact answer for this would be 5 squared, which is, so the exact answer is 25 pi meters squared. That's the exact answer. Do you see how the exact answer is kind of easier? You don't have to plug in your calculator. That's the exact answer. Pi is pretty close to 3, so our approximate answer should be pretty close to 75, right? So our area is approximately equal to, and then you plug in 3.14 in for pi. 25 times 3.14 is 78.5 meters squared. I want your answers in exact form and approximate form. Okay? All right, big key difference for letter B, and this is the last one we're doing. Big key difference for letter B. What is it? We have the radius, which is very helpful, which means I don't have to fix it.
It's already cut in half.
And it's cut in half, which means that what am I going to have to do to my area equation? What am I going to have to do? No. I'm going to have to cut it in half. If I have an area, my area formula, what's this the area formula of? What's this the area formula for? It's at the top. What's it the area formula for? It's the area formula for a what? No, for a, come on guys, this is an easy question. It's the area formula for a circle. It's the area formula for a circle. So is this the area formula we're going to use for this? No, this isn't a circle. What is this? It's half a circle. So you should, what should you do to the equation? Cut it in half. Area equals 1/2 pi r squared. Or pi r squared over 2. I don't care which. But order of operations matters. So we have 1/2 pi blank squared. What's going to go in that blank?
Number 7.
The radius, which is 7. What's 7 squared?
49.
49. So now we need an exact answer, which is what? What's half of 49? Hold on, what's half of 50?
25.
So what's half of 49?
20.
24 and a half. Pi yards squared. That is our exact answer. Why is this exact? It's got a decimal. Well, because it's an exact decimal. Don't worry about it. And then our approximate answer, you just plug it into your calculator. 24.5 pi, you plug that into your calculator. What do we get? 76.93. Can I get a second on that? 76.93. Yards squared. So, key things to pay attention to on your homework today and on your work. When you're finding the area of a circle, you just use the circle equation. When you're finding the area of a semicircle, what do we need to do? Half of it.